Hey everyone, Morgan here. So today we're going to be balancing redox equations that occur in basic solution, sometimes referred to as alkaline solution. And we're going to have the same set of rules with only one modification. So let's remind ourselves, step number one is find the half reactions. Step number two is balance everything. Except hydrogen and oxygen. And step number three is balance oxygen. By adding water to the side that needs oxygen. Now we're going to have a different step in number 4. Balance hydrogen by adding 1 water for every hydrogen needed to the side that needs hydrogen, and I'm going to underline that, the same number of hydroxide ions to the other side. I tried to be as clear as I could with that. Step number 5 is equalize charge. By adding electrons, equalize electrons, and finally add and cancel. Okay, now to be very straightforward with you, there are probably half a dozen different ways of doing this. I have presented here the method that students over the years have told me makes the most sense for people doing this their first time out. If you find other videos online or other textbooks talking about how to do this and they give you different steps, that's fine. Those steps probably work well also. It's just that this is the approach that my students have said is the most straightforward for them. So that's the reason I'm using it. Okay, so let's do an example here. PO3, 3 minus becomes PO4, 3 minus. And MnO4 minus becomes MnO2. That's step 1. 1 phosphorus, 1 phosphorus, 1 manganese, 1 manganese. That's step 2. 3 oxygens here, 4 there, so I'm going to need a water over here. 4 oxygens and only 2, so I'm going to need 2 waters. Okay. Everything up to that point has been exactly the same as it was before. Now, for step number 4, because I have 2 hydrogens here and none over here, I'm going to add 2 waters. 1 water for every hydrogen I need, plus at the same time 2 hydroxides on the other side. Okay, in the next step, 2 times 2 is 4 hydrogens. So I add 4 waters and 4 hydroxides. Okay? Now, there's going to be a lot of hydroxide and water to cancel, don't worry. Electrons. 2 minus and 3 minus is 5 minus. I have a 3 minus. I add 2 more. 4 hydroxides, 4 minus, 1 minus. I need 3 more minuses. 3 OH minus. Okay. 2 and 3. So I'll multiply this. Did I just write those hydroxides? I am so sorry, folks. That was not what I intended to write there. 3 electrons. So 2 electrons and 3 electrons. I'll multiply this by 3. I'll multiply that by 2. Whew, going to be a lot to write out here. So I have got 6 hydroxide plus 3 water plus 3 phosphite to give me 3 phosphate. 2 times 3 is 6 waters and 6 electrons for the next one. 6 electrons plus, that'll be 8 waters. 2 permanganate to give me 2 manganese dioxide plus, that'll be 4 waters and 8 hydroxides. And we go. Now, I can do a lot of canceling. 6 electrons takes out 6 electrons. Now I got 6 hydroxides and I've got 8. So all 6 will disappear and leave me with 2. 3 and 8 is 11 waters. 6 and 4 is 10. So all 10 will cancel and leave me with just 1. And I think I've now canceled everything out, which leaves me with 3. PO3, 3 minus, plus a water, plus 2 permanganate, and 2 hydroxides. Let's check our charge. 3 times 3, that's a 9 minus, plus 2 more is 11 minus. 3 times 3 is a 9 minus, plus 2 more is 11 minus. There we go. Same charge on both sides. Okay, folks, now it's time to practice. Thanks for tuning in. This is Morgan, signing off.